welcome to the best session of the day. We're going to be talking today about DevSecOps in the age of AI. And I'm Marcelo Oliveira, and I lead code quality and security products for GitHub. And today it's an immense pleasure for me to actually be co-presenting with my new best friend, 𝗦𝗲𝗀𝗀𝗀, from the Microsoft Defender for Cloud. We've been working on this for quite a few months now. And we're so glad to announce this to everybody today at Ignite. A little bit about myself. So I've been in application security for nearly a decade. And I would love just to see a show of hands. How many people here in the room have security in their job descriptions? OK, quite significant. How about development? All right. It's a kind of a mixed room. That's pretty good, like for DevSecOps session. So, look, I'm super proud of the amount of the evolution that we had on the application security industry in terms of improving the signal-to-noise ratio of the findings and the detections that we provided to our customers. But there is a sad reality to application security as a whole. Like, I would go and I would engage with customers quarter after quarter, year after year, and they would have the latest tools, the latest dashboards, and vulnerability fixes were just not happening. Every quarter, like the vulnerability trends keep piling up and going up and to the right. And the reality is that I think many times we forget that application security is actually a team sport. If you're in security and in application security and you don't have developers on your side, it's like you walking into a soccer field, for the ones who like soccer, like me, Brazilian guy, without your attack team. You're just having your defense line, and you're not going to be able to score many goals. It's going to be a very hard game for you. So you want developers on your side. And most of the time when I would ask a security leader, why are you not remediating these problems? And the typical answer and the traditional answer has always been, oh, because developers don't care about security. Have you guys heard this before? Yeah? Look, I personally work with thousands of developers throughout my career. First as a developer, then a development manager, then a product manager. And I'll say one thing, like, I've seen a different reality. I've seen developers actually care about fixing their technical debt. And actually, as a product manager, I hear all the time, like, how much my developers want to fix some of the technical debt that, of course, we don't have at a GitHub, OK? And I think the problem is people like me, the product managers in the room and us, who are always so focused on how do we deliver more customer value to our customers. And the reality is that fixing vulnerabilities is not free. And it doesn't matter what the security tools that you have tell you that, hey, I'm giving you this amazing suggestion. A suggestion is not everything. You still need to accept that suggestion. You need to verify the suggestion, that it conforms with your coding guidelines, that it doesn't break something else. And you need to test the hell out of these changes. So because it's not free, it's always a trade-off conversation. And that's why we see this great divide between development and security, because security and innovation velocity are seen as trade-offs. And I'm a firm believer that until we're able to much better automate the remediation of vulnerabilities, we're not going to be able to change this picture. But here's the good news or the bad news, depending on how you look at it. There is a duality to AI. And I don't think that there is any doubt that AI is completely transforming the way that we develop software today. And there should be no surprise that it's going to completely transform everything that we know about application security as well. But what is it? Is it the hero of our story, or is it the villain? Right? Like, I love charts because I'm an engineer, so I'm going to use some charts here today. I apologize for the ones who don't like them, but I think that they tell a good story, and it's easy to explain the situation here. This phenomenon that we're finding more vulnerabilities than we are able to fix is not a new phenomenon. It's been happening for at least a decade that I've been working in AbSec, and I'm pretty sure that it's been happening for decades before as well. And what is the result? As code accelerates and the gap continues to increase, we see an exponential growth in vulnerability backlogs. And So it's no surprise that when I speak to customers today, like in large banks and healthcare companies, etc., it doesn't matter who it is, it's not a surprise that I hear about hundreds of thousands of vulnerabilities or over 1 million vulnerabilities sitting in these backlogs, and they're asking, okay, where do I begin? Well, how do I start? It's impossible. I don't have enough people to fix all of this. And here's the kicker. AI is here and is producing 5 to 10 times more code throughput than we had seen in a very long time. Let me ask you guys one question. Do you think that the AI that an LLM produces is vulnerability free? No? I'll tell you, it's not. Okay? We test it and we have the statistics and we use it all the time because it's still going to produce first-party vulnerabilities. It's still going to try to use vulnerable dependencies, and sometimes it's going to leak a secret. And if nothing else changes here, imagine what's going to happen. If we continue with the status quo and we start using AI, this is what I like to call the collapse of application security, and I would even say that AI is just not going to stick. Nobody's going to be able to take advantage of all the speed that is being given to them because it's impossible, it's irresponsible. But I wouldn't be here if I believed that that's the trajectory where we're headed, okay? The reason why I'm GitHub for about a year now is because I've seen the writing on the wall, and I've been in startups for a long time in my career. And I think that there is nobody else who is better positioned between GitHub and Microsoft to really deliver and change this picture at scale. I actually believe that AI is the hero of our story. And the reason being that agentic capabilities like a Copilot coding agent, etc., give us an opportunity that we didn't have before. Remember, we were bothering developers with all these findings, all these things, and asking them to change their code. Now I can do this before they even see it. Imagine if we can put prevention straight into that agentic loop, and we can fix these problems with the LLM before they surface to the developer. This 5 to 10x increase in throughput of code is not going to translate in a similar increase in vulnerabilities. But that's not all. With agentic capabilities, we can start also looking at automating this whole remediation process in a way that we couldn't do before. And that's my dream, because if we do this, we can actually reverse this decade-long trend of increasing security debt, and we can see this start burning down security debt. And this is what I like to call the AbSec renaissance, which is what we here are trying to drive between Microsoft and GitHub, advanced security. And this is why I believe in this vision. Our vision is pretty simple. I believe that if this security becomes part of the platform in the way that software is getting created, we can come to expect a new world where every piece of software is going to be secure and high quality by default, and it doesn't matter if it was written by a developer or if it was written by AI. And by the way, the first part about that agentic prevention is not something that we're building. It's something that we have already announced, like, I don't know if it was 2-3 weeks ago, like at GitHub Universe. In the own Copilot coding agent loop, now Copilot coding agent is using all of the AI capabilities or all the code security capabilities that I have in the product today under GitHub Advanced Security to make sure that we fix dependencies, we fix vulnerabilities in the code, and we make sure that no secrets ever leak out of that system automatically. And the agent is pretty good at doing this, okay? So here's an example. Copilot coding agent runs the code QL against the YAML file that it just created, and it flags that, hey, you didn't set any permissions. You're being over-permissive about where you're defining this workflow. And Copilot coding agent says, oh, amazing, thanks for letting me know. Let me figure out what kind of permissions this file requires, updates the permissions, and runs it again to make sure that, yeah, I fixed the problem indeed. But today, we're going to be focusing on the second part of that story, which is how do we accelerate remediation and how do we start burning down those decade-long vulnerability backlogs. But should we fix everything? Let's say we have 2 decades of vulnerability sitting in our backlog. Should we fix everything? That would be irresponsible, wouldn't it? Imagine the amount of change that would have to come into the system and the likelihood that some of those changes are going to create problems. So I still believe that we need to prioritize vulnerabilities and understand which ones really matter to me today. And that's why we're announcing this integration here between Microsoft Defender and GitHub Advanced Security. Because every conversation that I had with application security leaders always boiled down to the same discussion. How do you prioritize? What would you like to use at the dimension of risk to prioritize vulnerabilities? And of course, they mention severity and all those things, and EPSS, et cetera. But it always comes down to, I want to know if this is running somewhere. Is it in production? And if it is in production, what is the level of exposure if this gets compromised? Does it have, is it internet facing? Is it exposed to what kind of data does it have access to? So if there is a compromise on the application, what's the impact? And once I prioritize, now I can go and scale remediation. And that's what we want to show you guys today, and we're so excited to have this launch. All right, and to share more about the security operations perspective and how we're thinking about this from the security operations standpoint, 𝗦𝗲𝗻𝗀𝗻𝗀.
Thanks. So we're going to mention the concept of application, and I want to break it down into two parts that actually represent what is application for us. On the one hand, we have the first-party code, as we call it. This is actually code created by your team. Okay, you own it, you create this project. Then there are third-party code, and in the industry we call it a software supply chain. Code contributed from the external sources, such as OSS. But you need to scan all of those code parts, and you need to protect it. On the one hand, you have the dev team. They are looking more on the left side, and their visibility stops just before runtime. They don't know how this code is actually running and what is happening in runtime. And on the other side is the security team. They have visibility in runtime, but their visibility to the left ends somewhere far from the true code owner. Now, let's talk about pain. Whenever I'm going to do some innovation, I always ask myself, what is the problem that I'm going to solve? Like, the problem space is so important. And we did this, again, this exercise here as we approach to this project. The SecOps persona, and I'm going in the next few minutes to talk about the SecOps persona, he has a couple of challenges. First of all, huge amount of recommendation. And Marcelo touched that. We cannot handle everything that we have in the system. Our team is too small, and there are many of them. But even once we decided, okay, this is super critical and I want to fix it, how do I go and fix it? Who do I talk to? The linkage between what I see and own and the developer who actually contribute those lines is broken. Those two teams are not well connected today. So I need to find the right owner. And once I think I found the right owner, and this is what usually happens, I send it out to those teams, and then a customer called this the black box experience. They send out the ticket, and they are waiting. And then something happened there, but they don't know. Usually what happens, the ticket will travel between different team members until it finally gets to the right hand of the true developer who owns it and can fix it. During that time, the SecOps persona, the poor guy, he gets called every day from his CISO. What is the status? What is happening? Give me ETA. He has no clue. We're going to fix all of that. So let's take a look how the product works and how the SecOps persona is going to see it. Speaking about seeing it, I will put my glass. Okay. What we have here is the Defender portal, and you have here the security posture, the runtime environment, and all the insights. And I have 97 critical issues reported by the system. I want to go and investigate. My default go-to is the recommendation list, which is huge. As I said, I cannot go and handle 96 critical items. I want to filter that list in a proper way. And there is a very easy way for me to go and do that and reduce the signal to noise. If I switch to attack path view, now I'm getting to see the toxic combination between vulnerable resources that represent a potential attack path. I will filter that list to make it a bit more concrete by looking at risk factor. In this case, let's choose internet exposed and access to sensitive data. I can also add the type of entry point. I will choose container. And to make it interesting, let's choose a target, in this case, storage account. So now I have my list. It's shorter than before and very focused for me, relevant to the job that I can carry. I will choose the first one. Here we see the attack path. Let's analyze what we see here. We have external access. Let's see what this guy is. Like, it's a load balancer. We can see, hopefully you can see it, that it's a public exposed, public IP. Yeah? Okay, so it's public exposed IP that lead eventually to the crown jewel that you see here. There are additional entry points, and I want to get rid of those potential attack paths in one click. I will search for what we call choke point. This is the point right here that if I treat this properly, the attacker, he actually stops here. He cannot continue and go all the way down to my crown jewel. When I say crown jewel, let's examine the reason it was marked with this nice icon. We have here interesting finding. A lot of PII information and financial records that are stored in this storage account. So it's definitely sensitive. Okay, I'm ready to go and take a closer look on the container and the findings that I have here. Ooh, the list is pretty big. And all of this is coming from our scan in runtime and registry scan that we do in the Defender for Cloud. I will choose one of them. There are associated CVE to this one. Let's click on it. We have 4 CVEs related to this recommendation, and this is something new. This screen is not new, but this section is new. You have here related GitHub alerts. If those CVEs are linked to the GitHub system, I would see a link, and I know that it's already marked and someone is assigned to this issue. But it's not. So I want to create this linkage between what I see as a SecOps persona in the Defender portal and the GitHub system. So I have here this tab, Remediation Insight. Isn't it nice? Now we finally see the linkage between code to cloud, all the way. We created a mapping that goes from the code itself in the repo through the build, ship, all the pipeline until runtime. This linkage helped me to map the most relevant repo and owner of those issues that I just discovered. There is another thing that is very interesting. Since this data live on a graph and everything is connected in the graph, I can link those vulnerabilities to all the impacted resources. So I know that there are 2, and if I will fix those, I'm actually fixing it for those 2. Now, let's take action. And I have here in the list, create GitHub issue. I click it, and the magic is done. On the back end, the system switch to the GitHub side and move the ticket over to GitHub with all the information that we just saw. We see that there is a sensitive data. The context from runtime is now part of what we see on GitHub. It's exposed to the internet, everything I filtered by. And most importantly, the exact 4 CVE that we looked at are now here, bucket together and ready to be picked. Okay, now my job is not done. I want to click into the repo and take a closer look on what inside the container. I'm going to see the application itself inside the container and the finding on that application. Thanks to the finding that came from GitHub Advanced Security, I have here a very interesting and critical issue to handle. The code scanning discovered a couple of issues, and I can see those issues here in the finding. It's a pretty big list. And that list is already linked to the GitHub side, and I can click and move again to GitHub to see the information and handle the case in GitHub. So we covered the perspective of the SecOps persona, and I want to go back to the presentation and call back Marcelo to take us to the dev persona.
Thanks, Oz. Thanks. Good job. All right, back to my demo now. One thing that thanks, Oz, for covering the details of the SecOps persona. Let's first take a quick look at the AbSec perspective. Like, again, Oz talked about some of the pain. AbSec also has this pain. Like, they really want to prioritize and focus the energy of developers on the things that matter most. But they lack that context until today. They didn't have this contextual details about what is the runtime information that can be used to now focus developers on the most critical vulnerabilities. And let's see also how we can address the remediation speed. Okay, so I'm going to switch to this demo very quick. And no surprise, now all that information that was available only to the security operations person is also available within GitHub. Have you guys all used GitHub before? Are you familiar with the GitHub experience? Okay, cool. So this is a new virtual registry capability that actually takes advantage of our actions pipelines where we can very, very easily sign and attest artifacts that are moving through the pipeline. So I see everything that is coming out. And here we see the Java web shop that Oz showed on running in production. And we see that there is only one version that is actually deployed to the cloud. And we already see some of those parameters that Oz was speaking about. Let's take a look and see how it actually works. So when I look internally, I see this provenance attestation, which is cryptographic proof of how exactly this artifact was built, including the commit hash that was produced, the workflow file that was used for that build. But most importantly to us is the fact that it includes all the repositories that are included in this container. So this is actually a many-to-many mapping of all these repositories going into artifacts, and then allows us, it's almost like basically an air tag that allows us to trace the code all the way into an artifact, all the way to production and back, okay? And thanks to MDC, now I see that this was actually pushed to the Azure Container Registry, that is deployed to production, has sensitive data, is internet-facing, and it's deployed to the East US region. But why do I care about this from an AbSec perspective? Because again, my goal is focus and remediation. So as an AbSec person on GitHub, I would typically live here in the risk on the security tab, right, of GitHub. And here I see that I have 114 findings that were related to first-party code vulnerabilities. I have also the dependencies that Oz spoke about, like in the context of Dependabot finding CVEs. But what we want is we want to drive remediation with developers. And what GitHub has always been is a collaboration platform for developers to collaborate with other developers on top of their code. And this platform has been now extended to also include collaboration between developers and agents, and also developers and AbSec. And one of the constructs that we created for that collaboration is this notion of campaigns. And from within a campaign, I can very easily filter the information that is most critical to me. So of course, let's start with the obvious one. I'm just interested on the open vulnerabilities. A typical application security person would look at the severity. Let's start with the criticals and highs. And then there is also now this runtime risk data that came straight from MDC to me. And from here, I can look at that internet exposed and sensitive data. So I went from 114 down to 9. But what's most interesting here is I can publish this campaign. I can give it a name. Let's pick Ignite Demo, short description. Okay. How much time should we give our developers to fix this 9 vulnerabilities? I think sprint ends next week. Let's give them until the end of next week. Okay? And I publish the campaign, and all of a sudden, this campaign is available to me, and as an AbSec manager, I can go and I can monitor the progress of this campaign. I can see how many have been closed, how many have been remediated, etc. But let's look at the more interesting side, which is the developer side of the house. I'm going to put my developer hat on, and I'm going to go into my actual repo where these vulnerabilities live. And as a developer looking at this repo, I'm going to see a campaign that it got published by my AbSec team show up right into my repo where I work and I see every day. But instead of seeing a list of tasks, what I'm looking at is a list of suggestions about how should you fix this problem. And of course, because we have Copilot behind the scenes here, like we have a Copilot auto-fix, let's take a look at one of those. Let's take a look at the code injection vulnerability. So for a developer who hasn't seen or understood the concept of what a code injection is, it provides a very good description of what the issue is, why it's a problem, using the actual code that the developer was using, and provides a very simple suggestion that, hey, you shouldn't be deserializing data using an eval statement on a JavaScript file. You should actually be using the JSON parse, which is a standard file. Okay? But remember that this is not just a matter of accepting this. I need to make sure that this complies with my coding guidelines and what my organization expects. So do I want to fix this one by one? What if we decided, no, I don't want to take this one at a time. Let me pick this. I like this. Or critical vulnerabilities. And controlled command line looks dangerous as well. Reflected cross-site scripting. And instead of trying to fix and accept every one of those suggestions one at a time, let me just assign this to Copilot. And what it did is it actually assigned Copilot to apply the auto fixes for selected alerts, and Copilot will open a PR. Let's take a look at the pull requests. And indeed, Copilot started working on a work in progress pull request here. That is iterating on the solution. It recognized that there are 5 vulnerabilities that were assigned to him. And over time, you're going to be able to watch the session. You can steer the session. You can guide Copilot in different directions the way that you want. Or you can go get a coffee and come back later, which is what we're going to simulate here. Okay? So let's take a look at this PR, which I have already created, because this is going to take a little bit of time, about 4 to 5 minutes. And we don't have that time today. So let's look at what Copilot did, indeed, or what it does. So here's the PR, and I can watch the entire session about everything the Copilot did to remediate this problem. And here I can see that there are actually a summary with it was able to fix all of the 5 vulnerabilities, verify them, and make it ready for me as a developer to now push it to production. And if you watch, there were only 2 files that were impacted, the package.json. We added escape HTML dependency so that we can actually fix the cross-site scripting dependency that is down here. The potential for command injection for unsafe execution is available here with the exact file. So everything got resolved. Every potential conflict got resolved automatically by Copilot and verified by the agent. Isn't that cool? Imagine the scale that it can reach now, burning down those decades of backlog of vulnerabilities by focusing on what matters, and now addressing and remediating this to scale. And as a developer, all I need to do is go back to the pull request. If I'm happy with the solution, I can add my review, approve, and get ready to merge. But remember that, actually, Oz, you found something, right, on your side of the demo that was not covered by depend_abort, right? So that was basically a dependency that was caught at the container scan. And GitHub Advanced Security doesn't have a container scanner today, but MDC does. And when he scanned the container, he found something on the image that we didn't catch on the application packages. And what can I do here? Like, Oz created this ticket for me. It's a new issue. I can go and assign this the same way that I did before and assign it to Copilot. And Copilot is going to do all this work for me. And look, I can jump straight into the summary. Let's go and view the entire session again. It did a lot of work up front because BusyBox is not something that you can find on your container description file. It's actually part of the base image. So we went through trying to analyze what exactly happened, where this BusyBox is, and identify that this was actually part of the base image of the application. And as a summary, it decided, hey, this version is vulnerable. I understand that I need to get BusyBox to 135.0. It figured out the base image version that would lead to being able to solve those 4 vulnerabilities that Oz found. Did some application testing to verify that it was compatible and still runs with this new version of the image. Tested, tried to execute against the HTTP server, issue an HTTP request, made sure that it came up, did all the work for me. So now I come back from my coffee, I can just say, okay, great, this looks good. I can see the test results. I can go back and just say, go back to my pull request, and as a developer, add my review and approve this. Okay? This is extremely powerful, guys. Like, this is really short-circuiting the way that we think about remediation to a level that it just wasn't possible before. And to speak a little bit about this from the point of view of a customer who has been using this for a while, I wanted to invite Manuel here to the stage to speak from the entity data perspective.
Thank you. Thank you so much, Marcelo. Yeah, it's as one of the world's leading the IT service company, we constantly inside on innovate securely, right? Today, we want to share how we were exploring securely an adoption Microsoft knee approach, secure code to the cloud with AI-infused DevSecOps, right? So the question we all face, how do we deliver it faster without compromising security, right? So like many organizations, we encounter the challenge of balancing innovation or security. Traditional development cycles left gaps, vulnerability, lack of traceability, a manual process slowing delivery, right? So we need a solution that integrates security simply from code to cloud. When Microsoft invited to entity data used to be the zero customer for this platform, we accepted. We tested it in real projects, and here's what we experienced, right? So the first is the native integration with the GitHub and Azure for frictional development experience. AI driving vulnerability analysis in real time, automate compliance and security policies. Finally, the first definitely session is global scalability for enterprise-grade delivery. So through this approach is we have seen improvement in vulnerabilities, remediation, speed and the secure delivery or critical application, and this enables you to innovate with great confidence. So this is not just technology, it's a culture achieved security as part of the NDA on development, and we are proud to drive this information alongside to Microsoft, right? So if you want to accelerate the innovation without compromise security now, this is the time. So welcome to the future of the DevSecOps.
Thank you. So I want to start to close this session, and this nice architecture actually tell the story. I will not read everything, but to summarize it, we have the two main products serving the SecOps team, serving the dev team, interacting with each other, creating context and creating a streamlined process across them. But we never stopped there. We gave you the agent capability to fix the code for you. And going back to the beginning, there was a dilemma. Speed versus security? Not anymore. Thank you.